All right, so we are completing the square today, and our goal for completing the square is to make a square on this side of the equation so that we can take the square root of it. So what we're going to do is we're going to make sure that we have the x squared and the x here, and then it's going to be equals c over there. So what we're going to do is we're going to have 2x, or x squared plus 2x equals 3, and I'm leaving some room here. Right? That's because in order to make this a square, I'm going to need to have this c term. So as you remember from our exploration, we would take the 2 and we would divide it by 2. So x plus 1 would be this, and we're going to square. So the square that we're trying to make is x plus 1 times x plus 1. So in order to get to here to see what to make that square, we would do 1 squared, which is positive 1. But since we're just kind of like magically adding this positive 1, we also need to add the positive 1 over here in order to keep my equation balanced. So I'm going to add these together. 3 plus 1 is 4. From there, I can see, okay, I have x plus 1 squared equals 4. And I want to get rid of this square, so I'm going to take the square root of this side, which means I also need to take the square root of this side. So I'm going to take the square root and the squared, and I'm left with just x plus 1 is equal to positive or negative because I'm taking the square root. Square root of 4 is 2. From there, I have like 2 separate problems here. I have x plus 1 equals 2 and x plus 1 equals negative 2. So I'm going to actually just subtract 1 on each side. So I have x equals positive or negative 2 minus 1. So if this was 2 minus 1, the answer would be 1. And if this was negative 2 minus 1, the answer would be negative 3. So that's how we get the 2 answers that x is equal to. So x equals 1 or x equals negative 3. Remember that means that if we graphed this equation up here, we would see one solution at x equals 1 and one solution at x equals negative 3, and we would see that graph that looks like this. Right, so we could still use that method. We're just learning another method today. So that's kind of the best case scenario for completing the square. If you turn to the inside, you should see a problem that looks like this. And this is what happens when you have a 2 out in front here or a number out there. So the first step is that we have to get rid of that. So I'm going to divide by 2 on each piece here. I'm going to divide the 0 by 2 as well. So that means that I have x squared minus 5 halves x minus 3 halves equals 0. So I'm going to leave it in fraction form, even though I know that can be kind of scary. I'm going to move the 3 halves to this side over here so that I can create some room for my square. So x squared minus 5 halves x plus something, that's me making the square, equals 0 plus 3 halves is 3 halves. Right? So now I'm going to go ahead and make my square number. So I have x. I see that this here is minus, so I'm going to put a minus here. And then I need to do half of 5 halves. So if I'm doing half times 5 halves, or half of 5 halves, that's going to be 5 over 4. So 5/4 is half of 5 halves. So I'm going to put 5/4 right here. If you need to use decimals, that is okay. That no problem. Just go ahead and use them there. And remember that we're squaring in order to figure out what goes here. So the way that we square that is we square the top and we square the bottom. So if I have 5/4 squared and squared, I'm going to get 25 over 16. That's what's going here, 25 over 16. And if I magically add this piece here, then I also need to add it on the other side in order to keep them equal, in order to keep the equation equal. So if I have this, I'm going to equal to. For this here, I'm going to need to add these together. So I have 3 halves plus 25 over 16. If I need to add them, I need to have common denominators. So I'm going to multiply by 8 on top and bottom here. So that'd be 24 over 16 plus 25 over 16 gives me 49 over 16. So that is what's going to go here, 49 over 16. I promise these fractions are going to work out. So now, if you remember, I want to get rid of the square. So I'm going to take the square root on both sides. And that's going to get rid of the square here. Give me x minus 5/2, or 5/4 is equal to positive or negative. And then when I take the square root, I take the square root of 49 over the square root of 16, which is super duper nice because the square root of 49 is 7 and the square root of 16 is 4, which actually is making my fraction life a lot better. So then I'm going to add 5/4 on both sides. So that means I have x equals positive or negative 7/4 plus 5/4. Okay, so in one situation I would have 7/4 plus 5/4, and in another situation I would have negative 7/4 plus 5/4, which would give me 12/4, or 3, or would give me negative 2/4, which is 1/2. Right, so we can start to solve those super duper difficult ones. Honestly, this would probably be one I'd use with a different method, but we can use completing the square to do this way. Cool. The last one is this one over here. We're going to work within this one. So we can solve this in the same way. So I'm going to make some room for my square. It's going to leave me with x squared minus 2x plus something, right? This is gone, is equal to negative 2. We're also going to add that something over here. So I'm going to make my square. X, I'm going to take this divided by 2. It's going to give me negative 1. Negative 1 squared is positive 1, which I'm also adding to the other side here. So that's going to give me negative 2 plus 1 would be negative 1. I'm going to go ahead and take my square root of both sides. It's going to cancel here and leave me with x minus 1 is equal to, and I know the square root of 1 is just 1, but because of this negative, I'm going to have that I there, right? Don't forget that it is plus or minus I. So I took the square root. The square root of 1 is 1, so I could call this even like 1I, or just I, either way. And then I'm going to add 1 on both sides. So I have x equals plus or minus I plus 1. So in one way, I'm going to have I plus 1. In another way, I'm going to have negative I plus 1. Remember that with my imaginary numbers, I always write the real number first. So 1 plus I, that would be how I rearrange that. Or positive 1 minus I. That'd be how I rearrange that one. So this is what happens when I have two imaginary numbers. When I graph this graph actually looks like this, which is fairly interesting. So I'm able to find those solutions. Previously, we called this no real solution, but that does mean that we have two imaginary solutions, which are here. Cool. Thanks, guys. Ask as many questions as you have. I'm happy to answer them.